Hi, today we are going to see generating association rules for frequent item sets. In our earlier videos, we have seen how to solve the a priori algorithm. So, once we have solved the a priori algorithm, we will be getting the frequent item sets. So, even in the previous video, we have solved the same problem and we have got two sets of frequent item set, which is I1, I2, I5 and I1, I2, I3. Now let me take one frequent item set and see how the association rules will be generated for this frequent item set. Let's try an example based on the transaction data for all electronics shown in table. So suppose the data contain the frequent item set for the list I1, I2, I5, then what are the association rules that can be generated from this list? The non-empty sets of this L, what are all could be the non-empty sets that could be generated from this list frequent item set is I1, I2, which is I1, I2, then I1, I5, which is I1, I5. Then we'll have I2, I5, which is I2, I5. Then all individual items where it is I1, I2 and I5. The resulting association rules are shown below. So these are all the different rules. These are all the different rules that we have generated here for this list. You could see here L1, I2, L1 and I2 that tends to I5 and I1 and I5 that tends to I2 and then I2 and I5 that tends to I1. I1 alone, this is a one individual set. So individual set that is having an individual item I1 that implies I2 and I5 and then I2 that implies I1 and I5 and then I5 that implies I1 and I2. So now for each and every rule that we got here with the rules we have generated here, we will be calculating the confidence. And based on that confidence, we will see whether the rules are strong or not. We have given in this problem, we have given the minimum confidence to be 70%. So whatever the rule that is generating the confidence 70% and above 70%, those rules will be considered to be the strong rule. Here we know confidence is equal to by 4 50% and confidence is equal to 2 by 2 100%, and for this rule confidence is equal to 2 by 2 equal to 100%, and for this fourth rule confidence is equal to 2 by 6 equal to 33%, and the fifth rule where confidence is equal to 2 by 7 which is 29%, and for the last rule which is confidence is equal to 2 by 2 equal to 100%. So how we got this 2 by 4, 2 by 2, 2 by 6, 2 by 7 and all? We'll see this very elaborately now. So when you look into this, so the first rule is I1 and I2 tends to I5. So how will we calculate the confidence? So the support count of I1, I2, I5, all the occurrences of all the elements divided by the occurrences of I1 and I2 alone, which is the left hand side. These are all the non-empty sets that we have generated from our list of frequent items. We had I1, I2, I5. So we generated 6 sets. So the support count of all the items occurrence divided by the support count or the occurrences of the non-empty sets that we have generated from our frequent item set. So the support count of I1, I2 and I5. So if we take I1, I2 and I5, let's see where we are all having this I1, I2, I5. Here we have I1, I2, I5. Then I have it here. So only 2 times it had occurred. So the support count of occurrences or the occurrences of I1, I2, I5, the support count of I1, I2, I5 is 2. Now when we come to support count of I1 and I2, which is the non-empty set that we have formed, the occurrences of I1, I2 is I1, I2, and then here you have one I1, I2, then here you have one I1, I2, then here we have one I1, I2. So 4. So the support count of I1, I2, I5 divided by support count of I1, I2 is 2 by 4, which is 50%. So here, as I told you already, our minimum confidence is 70%. So this is just 50%. So this rule is rejected. So when we come to the second rule, the rule here is I1 and I2 implies I2. So as we know, the confidence is the support count of I1, I5, I2 divided by the support count of the non-empty set that we have generated, which is I1 and I5. Now let me look into I1, I5, I2 count. So I have it here, I1, I2, I5. Then I have it here. So the support count of I1, I5 and I2 is 2, and the support count of non-empty set, which is I1 and I5. So I1 and I5 I have here, and then I1 and I5 I have it here. So just 2. So 2 by 2, 2 by 2, support count of I1, I5, I2 divided by support count of I1, I5, which is 2 by 2 equal to 100%. Now this is greater than 70%. So this rule is accepted. So this rule is accepted. Now when we come to the third rule where I2 and I5 implies I1. So now we'll find the confidence where the support count or the occurrences of I2, I5, I1 divided by the support count of the non-empty set that we have generated, which is I2 and I5. So now let us see the occurrences of I2, I5 and I1. So I2, I5 and I1, I have it here. Then I2, I5 and I1, I have it here. So the occurrences of I2, I5, I1, which is the support count of it is 2. Then the support count of I2, I5. So I have I2, I5 here. Then I have I2, I5 here. So again 2 by 2, which is nothing but 100%. So this is also greater than the 70%. So this is also accepted. Now let us look into the fourth rule, which is I1 implies I2 and I5. So now what we'll see, the support count of all the combined elements I1, I2, I5 divided by the non-empty set that we have generated, which is I1. So now what happens? The occurrences of I1, I2, I5. Let us look into the occurrences of I1, I2, I5. Yes, I have here I1, I2, I5. Then I have here I1, I2, I5. So 2 times it had occurred. So 2 times. Now the support count of the non-empty set that we have generated, which is I1. So 1 here, I have 1 I1 here, I1 here 2, 3, and then 4, 5, 6. So the occurrences of the non-empty set I1 is 6. So 2 by 6 is 33%, where the minimum confidence of our problem is 70%, where we have got just 33%. So this rule is eliminated. So now when we come to the fifth rule, which is I2 implies I1 and I5. So now the support count of all the occurrences I2, I1 and I5 divided by the support count of non-empty set that we have generated. So the support count of I2, I1, I5. So let me check. I2, I1, I5, I have it here. Then I have it here. So 2 times. Then what happens? The support count or the occurrences of non-empty set that we have generated I2. Let's check here. I have 1 I2 here. I have 2. I have 3. I have 4. I have 5. I have 6. I have 7. So 2 by 7, which is the 29%. So again, this is not satisfying my minimum confidence. So I'm rejecting the fifth rule also. Now when we come to the confidence of the sixth rule, where I5 tends to I1 and I2. So now the confidence will calculate with the support count or the occurrences of I5, I1 and I2 divided by the support count of the non-empty set that we have generated from our list. So now let me check the support count of I5, I1 and I2. So I5, I1 and I2, I5, I1 and I2. So these two are the two occurrences of I5, I1 and I2. So I am putting 2 here. Now let me check what is the occurrences of I5. So I have one I5 here, I have one I5 here. So it will be 2 again. So the occurrences of I5 is 2 again. So 2 by 2 is 100. So which is greater than 70% of the confidence. So this is also accepted. So three rules are actually satisfying our criteria, where rule 2 is getting satisfied, rule 3 is getting satisfied, and rule 6 is getting satisfied. So our 2, our 3 and 6th rule are getting satisfied. So all these rules are considered to be the strong association rule of the frequent item set that we have seen for I1, I2, I5. So these three are the strong association rules that we have generated. So like this, we'll be generating the association rules for the frequent patterns or the item set generated. So for the same problem, there is also another item frequent item set, which is I1 and then I2 and then I3. So this is the another frequent item set. So you can try of yourself what are all could be the list of rules that we can generate from this. So for example, I can say you here also you will generate 6 rules. Here also you will generate 6 rules where this I1 and I2 tends to I3. I1 and I2 tends to I3. This could be the first rule. Then what happens? I1 and I3 tends to I2. Then what happens? What will be the next one? And then I2 and I3 tends to I1. So these are all will be the first 3 rules. Then what happens? I1 tends to I2 and I3. Then I2 tends to I1 and I3. Then I3 tends to I1 and I2. So like this, we'll be writing the 6 rules again for this list of frequent items. Then the confidence will be calculated. As it is coming from the same problem, the confidence level will be 70% for this also. So based on this rule, we will be calculating the confidence. So again, the confidence will be the same. Support count of occurrences of all the items, all the 3 items, divided by the support count of the item set that we have generated. So what are all could be the item non-empty set that we can generate from I1, I2 and I3. We can generate I1 comma I2. We can generate I2 comma I3. We can generate I3 comma I5, and then we can generate, this is the combination of these two items. Then again we can generate a 3 non-empty set, which is I1, I2 and I3. So all these empty sets will be forming the left hand side of the rules. So I1, I2 tends to I3, I2, I3 tends to I5, I3 and I5 tends to I1, and then I1 tends to I2 and I3, I2 tends to I1 and I3, I3 tends to I1 and I2. So likewise, we'll be writing the 6 association rule, and the confidence will be calculated based on the support count of occurrences of all the items divided by the support count of the non-empty set that have been generated correspondingly. So hope you can understand this. This generation of strong association rules also plays a major role in a priori algorithm. So we generate the frequent item sets, we need to know what are all the strong association rule in combinations are getting generated for the each and every frequent item set. So a priori have a greater disadvantages, such as for each and every time we are scanning the databases. Even for each and every rule that we have generated, for every rule we are, for the left hand side as well as the right hand side of the rule, we are scanning the databases. So this is the most disadvantages in the a priori algorithm. So that is why we are going for the FP growth, which was already put in the in our channel. So you can also check out the FP growth. I hope everybody understood this clearly. You can also try the next frequent item set I1, I2, I3, and you can check yourself how well you understood for the generation of strong association rule. Thank you.